All right. Is this vulnerable? What's the difference between this and the code we were looking at before? Stack allocated, I heard you say? Yeah, right. So the difference is this buffer here, rather than being part of global memory, is now allocated on the stack frame. It's a local variable, so when the function call returns, then that goes away. But still has the same problem. It's a fixed length buffer. If you enter an input that's longer than that fixed length, you'll be writing past the end of it onto something else that's on the stack. And if that something else is important, you might have a problem. Yeah?
So because it's on the stack, it's, let's say we have a variable instantiated after that, is that guaranteed to be after the buffer on the stack?
Let's not get too far into what the C language guarantees, because the C language specification kind of doesn't guarantee much of anything. It's designed to provide compilers flexibility. Instead, look at how things are actually laid out in the program you care about attacking. And usually you can download a copy of the program and see what's actually laid out there, and you can tell what else is after it. And then you can figure out, was that something important? And we're about to talk about that in a moment. All right. Anyone who knows what malloc does, that's dynamic allocation, allocating on the heap instead of in the stack. Is this still vulnerable? How many say yes, it's still vulnerable? How many say no, now we're safe? Okay, talk me through a reason why you might say it's safe. Yeah? Okay, so this is on the heap, so this would be writing past the end of the heap. And I guess you're saying no big deal if you're writing under the heap? The stack and heap are separate parts of memory.
So if you write something past the bounds of the pointer, it won't go necessarily into okay, never mind.
Someone want to give me a reason why it is a problem? Yeah, in the red or orange. Yeah. Yeah, okay. So it's still a fixed length buffer. So even though the stack and the heap are separate, you can still be writing past the end of this buffer, which means you'll be writing stuff in the heap now. And if there was something else important in the heap, then you got a problem. Yeah, okay. So still vulnerable. Still vulnerable. This stuff, these buffer overflows, we're going to study them some more. I want to just give you some motivation for why you should care. These problems are endemic, and here would be an example. Google was hacked. Well, this is now kind of old history, but this is a big deal at the time because, it was kind of surprising. Here's one of the most sophisticated, technically sophisticated companies around, and even they got hacked. And they got hacked by, well, it was believed to be by China. It was believed to be going after some activists. They wanted to learn how to I don't know. It sounded like the attack was trying to target the Google authentication system so that they could gain access to Gmail accounts of activists. And what was the flaw that allowed them to get in? Well, they exploited a vulnerability in an IE browser run by a Google employee. And here was the vulnerability. And the vulnerability was basically something like a buffer overflow. It was writing to a pointer, in this case, after the buffer had been deallocated.